Introduction to Hadoop. In this video, we are going to talk about Introduction to Hadoop. Introducing Hadoop. The most well-known technology used for big data is Hadoop. It is actually a large-scale batch data processing system. Data the treasure trove. It provides business advantages such as generating product recommendations, inviting new products, analyzing the market, and many more. Provides few yearly key indicators that can turn the fortune of the business. It provides room for precise analysis. If we have more data for analysis, then we have greater precision of analysis. Why Hadoop? Ever wonder why Hadoop has been and is one of the most wanted technologies? The key consideration is in capability to handle massive amounts of data, different categories of data fairly and quickly. Key consideration of Hadoop includes inherent data production, low cost, computing power, scalability, and storage flexibility. Hadoop versus RDMBS. Hadoop, node-based flat structure system, suitable for structured, unstructured data, supports variety of data formats in real time such as XML, JSON, text-based flat file formats, etc. Analytical big data processing. Big data processing which does not require any consideration relationships between data. In a Hadoop cluster, a node requires only a processor, a network card, and a few hard drives. It costs around $4,000 per terabyte of storage. Relational database management system. It is suitable for structured data. OLTP is the processing here. When the data needs consideration relationship, needs expensive hardware or high-end processor to store huge volumes of data. It costs around $10,000 to $14,000 per terabyte of storage. Distributed computing challenges. Although there are several challenges with distributed computing, we will focus on two major challenges. They are hardware failure, how to process this gigantic storage of data. Challenges: hardware failure. In distributed systems, several servers are networked together. This implies that more often not, there may be a possibility of hardware failure. And when such a failure does happen, how does one retrieve the data that was stored in the system? Just to explain further, a regular hard disk may fail once in 3 years, and when you have 1,000 such hard disks, there is a possibility of that at least a few being down everything. Hadoop has an answer to this problem in replication factor (RF). Replication factor connects the number of data copies of the given data item or data block stored across the network. How to process this gigantic storage of data? In a distributed system, the data is spread across the network on several machines. A key challenge here is to integrate the data available on several machines prior to processing it. Hadoop solves this problem by using MapReduce programming. It is a programming model to process the data. History of Hadoop. Hadoop was created by Duck Cutting, the creator of Apache Linux. Apache is a part of Apache Yahoo project and also a part of Linux project. The name Hadoop. The name Hadoop is not an acronym. It is a made-up name. The project creator, Duck Cutting, explains how the name came about. The name my kid gave a stuffed yellow elephant. Short, relatively easy to spell and pronounce, meaningless and not used elsewhere. Those are my naming criteria. Kids are good at generating such. Google is a kid's term. Hadoop overview. Open source software framework to store and process massive amounts of data in a distributed fashion on a large cluster of commodity hardware. Basically, Hadoop accomplishes two tasks. download, use and contribute. Framework means everything that you will need to develop and execute an application is provided, programs, tools, etc. Distributed divides and stores data across multiple computers. Computation and processing is done in parallel across multiple connected nodes. Massive storage stores colossal amount of data across nodes of low-cost commodity hardware. Faster processing. In faster processing, large amount of data is processed in parallel, yielding quick response. Hadoop components. There are two types of components. They are Hadoop core components and Hadoop ecosystem. In Hadoop core components, there are two types, HDFS and the MapReduce. In HDFS, a storage component distributes data across several nodes, negatively redundant. In MapReduce, computation framework splits a task across multiple nodes, process data in parallel. In Hadoop ecosystem all support projects to enhance the functionality of Hadoop core components. The eco projects are as follows: Hive, Fig, Squid, Hibase,